Hello, in this video I'm going to explain you differentiation using a practical example. Here we have a temperature of a cake as a function of time as the cake has been taken out of oven. And as expected, temperature of a cake is dropping as time goes forward. And from this graph we could easily read what's the temperature at when time is 80 minutes, for example. We can see temperature is roughly 40 degrees. Now, if we would be interested in knowing how fast temperature of this cake is dropping, we could calculate average rate of change of temperature using 2 points. So if I add these 2 points A and B on a curve, we can calculate average change of this average rate of change of temperature by calculating how much temperature is dropping divided with how long it takes. And here is our answer how fast temperature is dropping on average, calculating using coordinates of these 2 points. Now we get the same answer if I draw a straight line through these 2 points and I'm using equation for this straight line. We get same answer from the gradient of this straight line. So temperature is dropping on average 1.3 degrees when time goes from 20 to 60 minutes. Reason we get the same answer is because gradient for this straight line is calculated exactly the way we just calculated average rate of change of temperature. Now this gradient is really important here, and that's actually the key, and that's where I'm heading when we are talking about differentiation. Now, if we would be interested not to calculate average change of temperature, how about if we are interested in calculating how fast temperature is dropping, for example, here at 60 minutes? And the way we would be doing that is I remove this point and 1 point and one straight line, and now I have this only this 1 point here. And if I add something called a tangent line going through this point like this, we can see this tangent line is touching this curve only in this 1 point. And here is the equation for the tangent line going through this 1 point. And what we are interested in again is this gradient of this tangent. So temperature of this cake is dropping 0.78 degrees per minute when time is 60 minutes. And this is actually what differentiation is all about. We are trying to find values of gradient of a tangent drawn into a curve, because this gradient will give us the value how fast values of certain curve are changing. And that's what differentiation is all about. And as I move this point here in the beginning, we can see that value for this gradient is more and more negative, meaning the temperature of this cake is dropping faster when time is here in the beginning. So here, temperature of this cake is dropping roughly 3 degrees per minute, but as time goes forward, you can see that how fast the temperature is dropping is actually getting smaller. So now at the end here, temperature is only dropping like 0.1 degrees per 1 minute. And that really makes sense, because when the cake is hot, it will be cooling down faster. And as the temperature gets closer and closer to room temperature, the cooling rate will be getting smaller and smaller. So what's interesting here, or what's the important part here, is that differentiation is all about gradient of a tangent drawn into a certain curve, because that will give us how fast the values of function is changing. And usually we don't have graph like this to do the calculation, or program like this to do the finding the values for gradient of a tangent. And that's where we need something called differentiation rules, so that we can find a derivative function which can be used to calculate these gradient values for the tangent in a point of interest. But that will be a topic of another video. See you in the next video.